Good afternoon from the UK, and good morning to those of you in the rest of the world. This is another in the series of the Beyond Modelling webinars from the Lanner Group. My name is John Beadsmore. I'll be presenting the session to you today entitled Common Modelling Challenges. Today's session will be approximately 30 minutes long. Hopefully you will be able to hear me clearly. If you have any problems or you have any questions, please use the chat function on WebEx to put a question through, and we'll see if we can deal with it whilst continuing with the presentation. Today's session on Common Modelling Challenges, we're going to cover in these sessions areas that are often raised by witness users as questions to Lanner's support desk, issues that we often face as Lanner consultants using witness on project assignments, and try and show you some of the typical approaches for these challenges based on our own experience of doing this numerous times using witness, and hopefully explaining some of the flexible use of witness elements, different ways to use some of the elements in witness. Just because a machine is called a machine in the designer elements doesn't necessarily mean you need to use it as a machine. We can use it in other ways, and hopefully we'll show some of that today. Obviously, common modelling challenges is a broad subject area, and other aspects of will be covered in future webinars. For today's session, what am I going to cover? Well, the advantage of this session being recorded and then available to you on YouTube means I can try and cram quite a bit in half an hour, so some of it may go quite quickly. There's a fair bit to include, but you'll get the chance to review that on the YouTube videos that will be published shortly afterwards. Today I'm going to show you how we can use witness machines to represent labour, so a different use of the standard machine element in witness, use of parts to trigger actions, alternative modelling of shifts, and use of the system variable n to control the number of resources that we have in a model instead of using the shift element itself. Using labour to represent a computing resource, so a different use of the labour element. And I'm going to build all of those together into a call handling facility example to demonstrate some of these, and then demonstrate at the end how that makes an easily scalable model from a small customer service bureau to a large call centre operation. With any modelling exercise, we normally start with a process definition. So here's the process definition for the model I'm going to construct for you today. It's fairly straightforward in terms of a call handling process. So on the left hand side, a call arrives in our system. It will be placed into a call queue. If we have available agents, they will pick the calls out of the queue, answer the calls, deal with those calls, and the call will be completed after a certain length of time. If all the agents are busy and the calls in the call queue are not answered within a specified amount of time, then there will be the option for the caller to abandon. In some circumstances, this may then generate another new call into the system. We won't pick up that particular line today, which is the dashed line you'll see on the screen, but we will be reflecting the number of abandons in the system. Additionally, when the call agent is taking the call, there will be an option to include for specialist software to be used by the agent. So we're going to include that at the end, which is where we'll pick up the idea of using labour as a computing resource in the model. Okay, I shall break out into Witness now to start building this model for you. I am going to build it from scratch. The only aspect that I've got prepared in advance for this is an Excel front end with a bit of data in it. I've got two sets of data here. I've got my staffing profile and a call volume profile, both by 15-minute period of the day, just for a single day. So these go down to 96 separate rows covering a full day's worth of information. So to construct our model, to begin with, I'm going to pick up some elements from the Designer Elements window, drag them onto the witness layout window. So I'm picking up a part, I'm picking up a buffer to represent the queue, and I'm going to pick up a machine to represent our agents in a moment. Going into the detail for the part, this is going to be our caller. So the part is the caller, or the telephone call that's going to come into our system in the model. For the moment, I'll just OK that. The caller is going to be pushed using the in this case the visual output rules into the queue over here. OK. The queue itself, if I go into the detail for the queue, I can give that a new name. We'll call that our call queue. And in this case, to allow for the abandoned calls, I want to create a maximum delay queue, i.e. a call can reside in this queue for a maximum length of time, within which, if the call isn't pulled out by an agent, the call will abandon or disappear out of the system. The maximum time I shall use, I'll pick up a distribution. We'll pick the uniform distribution, and I'll say that callers will hold on to the wait to be answered for between 2 and 5 minutes. So that maximum time will be sampled each time we get a caller into the queue, and will generate their own time for how long they will wait to be answered. And if they're not answered within that time, they will be subject to the exit rule, which in this case I'm going to say push to scrap, so we'll get rid of them out of the system altogether. Okay, so they will disappear if their call isn't answered. So I also need to change the output option to any on this queue, because we're generating different waiting times. Then any call could disappear out of the queue at any point in the process. The call queue itself, so we're going to create the calls to be pulled into our agents. So the machine I've created over here, I'm going to rename as agent. I am going to create a call handling time, which will be effectively the cycle time for this machine, our agent. This time I'll use a triangle distribution, insert a triangle distribution, and I can say that the calls will occupy or last for a minimum of 1 minute, a mode of let's say 4 minutes, and a maximum of 7 minutes. I'm defining my time units to be minutes, so anywhere in the model where I'm entering times, minutes is the unit that I'll be using. So I'll select OK on that. Again, selecting the agent element now, selecting the visual input rule option, I can pull the calls in from the queue into our agent here, and likewise the visual output rule, push to ship in this case. So that's set up the flow of my model. I can just stick the element flow rules on just to see the flows that I've created, which is shown there, and turn those off again to improve the display a little bit, clear the display. I'll alter the display of the agent element here, so through the display option I can update the icon for my for the agent itself to make them look a little bit more like an individual rather than a machine. Okay, I'm also going to just reposition the part queue and labour queue. So let's put the part queue in front of the agent, and I'm going to put the labour queue down in front, which will become apparent in a short while. And I can create a number of these agents now, so perhaps we can say we've got 10 agents in our system. So I've created the flow, I've created the call queue, I've created the agents. I just need to attend to the call arrival pattern now. So if I go back into the detail for the calls, this time I'm going to select an active with profile option. When I do that, that gives me an arrival profile tab in the detail of the parts screen. If I move across to there, that gives me this grid where I can create an arrival profile by time segment of the day. Now what I'm going to do is I'm just going to load this in from Excel. I need a different display because I'm going to go with simulation time. And now if I select the import from Excel button and go into my previously created Excel file, what I want to load in now are both the length of the period and the call volume. So that's these two columns here which I previously created. So we can see at the beginning of the day we don't get any calls coming in until we hit 6 o'clock, and then we start to get calls, and they build up through the day and they create a bit of a pattern until we get right down to the end of the day. So my column range there is J6 to K101, so it's specifying the data in all of these columns. I select OK, drop back into witness, and now that information has been loaded into my arrival profile dialog, and if I scroll down we can see that data is shown in there. So I can select OK. So we can now, if I run this forward briefly, then I should be able to check that things are starting to work. So if I run that, I've got calls coming in, they're coming into the call queue, they're being answered by the agents, as we can see. At the moment with 10 agents, I've always got 10 agents on duty throughout my 24 hours of the day, so we didn't get calls coming in until 6 in the morning, and it looks like I've got plenty of agents on to answer these calls. So that's all good. We're starting to get a model working together. I will just save this model whilst I'm working on this, so as we don't lose the anything if we have an issue. So let me just call this demo 2. Always wise to save your work as you move along. Okay, so we've started to create our model. We're using machines as agents, and we've got a representation, but it's not really very accurate yet in terms of what we're in terms of what we want to represent. And I'm not really displaying any of the statistics at the moment around around this model. If I run this model for 5 days, I use that as my time period, it will run the same call pattern over each of those days. It'll recur, the 24-hour pattern will recur. So now if I run this through to the end of 5 days, I can look at my statistics, see what I've got, see how many calls I've generated over the week. I'm not scrapping anything, so we're not losing any calls that are being abandoned, because everything is being answered at the moment by the agents. And if we look at the statistics on the agents, then again they are idle for about 78% of the time, so there's plenty of capacity to answer the calls. If we were to reduce these agents down to a much lower number, let's say 3, then if we run that through, then we can see the call queue moving as we go through the week, but we will be starting to lose some calls now, and as we get to the end of the week, end of our 5-day period, if we look at the statistics, then we've lost a significant number of calls now, 1,398, over the week. So this is all just still testing the model out at the moment. I'm going to put that back to 10. Okay. What I might want to do now is display some of those stats on the screen to help me interpret my model. So if I go to the Variables tab on my Designer Element window, I'll pick up an integer variable first of all, and I'm just going to call this abandoned, so I can check how many abandoned calls I've got from the call queue. So if I go into the call queue, and in actions on max, I can put abandoned equals abandoned plus 1. So that's going to count the number of abandoned calls that I get in the abandoned queue that have been scrapped. Again, now I might want to start counting the calls, the total number of calls that I've got, plus those that are answered within a certain threshold. We might be interested in the percentage of calls answered within 30 seconds. That's a typical performance standard that you might see in a call center environment. So let's add another integer onto the screen, and I'm going to call this one answered, and I'm going to give it a quantity of 2. Okay. Now in the call queue, as the calls are answered and pulled out, I can put the number of answered calls, I can add them up here in my actions on output. So answered, answered, and I'll need to reference the first position in my answered variable. So that's going to check the number of answered calls. Additionally, if I want some sort of performance measure, then I'm going to say if, and I'll use the function time in buffer, so the time that the call has spent in the buffer. The buffer I'm interested in is the call queue, and it's the call that's at the front of the queue, the one that's being pulled out at the moment, that's being answered, that I'm interested in. And I'm going to say if that's less than 0.5, i.e. less, it's been answered within 30 seconds, I'm going to update another counter. This time I'm going to use answered again, but I'll use the second position in the answered variable. So again, I'm going to increment that counter by 1. Okay. There's one more thing I need to do to complete this, but I'll just show you the example now as this runs through. If I run this through now, I'm getting the answered count moving along nicely, and we're answering. We can see we've answered 3,209 calls at this point, and 3,168 of them were answered within our 30-second threshold. If I calculate that value on the screen, I can add a real variable, and this time this will be my call performance. Okay, and back in the call queue, in my actions on output, I can say call performance equals, and I'm going to say the number of calls answered within my 30 seconds, which is the answered to statistic, and divide that by the total number of calls, which is my answered 1 statistic. I'm going to multiply those by 100 just to take out the decimal places and give us a true percentage value. So now when I run this, we can see a percentage of calls calculated within our 30-second time frame. One of the aspects of the that I need to account for is the fact that in the call queue, actions on output is triggered for every entity or every part that comes through the call queue, whether it's being rejected through the actions on max or whether it's being pulled into the agents. Now, currently my actions on output takes account of all of those, so I'm not getting a true, if I get any abandoned calls, I'm not getting a true calculation of the performance, so I need to allow for that. So what I'm going to do is I'm going to create an attribute over here. Let's just create an integer attribute. I'm going to call it scrapped. Create that. In the call queue itself then, in actions on max, I'm going to say, I'm going to set that to scrapped equals 1. So if a call is scrapped, it's going to set an attribute for that call of scrapped equals 1. Then in actions on output, I will only perform this calculation if scrapped equals 0. So I only do my performance calculations for calls that aren't scrapped. So that will give me now a correct calculation of the call performance. Okay, what I want to do now is to incorporate the my staffing profile. In my Excel sheet I have various staffing numbers across the day. They also start at 6, so my first agent comes on at 6 o'clock in the morning. And rather than have individual shifts for each person or each group of staff, because typically in a call handling environment you get quite a wide number of variations in shifts, it is easier to determine how many people you have on duty by 15 minutes of the day, and then we can use that in the model to determine the resources available to us, so we can see how these numbers move and change by 15-minute period. So that's what I want to reflect in the model next. If I create then something to read that in, I'll select another integer variable. I'll call this my staff, and I'm going to need a quantity of 96 because I've got 96 15-minute periods in the day. Okay. I'm now going to use the Excel wizard to read that in. So I go into my actions for initialize within my staff variable, select the Excel option, select my file, which is my demo1.xls file, go into Excel, and now I want to read in the number of staff. So it's just my staff volume column that I'm reading in. So I specify that column down to the end of the day, select OK, back into witness. Now I can just edit out the path here to avoid me, if I share this around other machines, then it won't lock in my path. So if I just leave in the name of the Excel file, then that will work. Okay, so let's just check that that's reading something in. If I just run that forward and then stop, if I then scroll down, I can see it's read in those values for me into my staff variable, so that's good. What I'll also do is cut that action out of there and move it into my main initialize actions. Okay, so I'm cutting it out of there and I'm pasting it into my main initialize actions. This is just so as I don't lose track of the actions I've got reading in from a spreadsheet, and I also can set the order of execution of a couple of other items that I'm about to set up now. Okay, now I need another integer variable that is going to hold the number of staff on duty at the current point in time in the simulation run. So I'll create another variable. I shall rename this as on duty. Okay, just has a value of 1. In my initialize actions, having read in the values into my staff variable, I can now set on duty to be equal to the first position in my staff array, effectively, because that's the first item of the day. That's the first staffing element that we're going to be reading. Okay, so that's initialized that. Now I'm going to create a part to use as a trigger. So in my simulation branch I can right click, define and add a part, and I'm calling this trigger, create, close. So this trigger is going to be creating a part every 15 minutes. So I select active, and I want a part to arrive every 15 minutes, and every 15 minutes I want to update the number of staff on duty from my staff variable that I've read in. In this case, my first arrival wants to be at 15 minutes, and as this part is purely a trigger, it's just a dummy part, I can push to scrap to get rid of it and remove it from the model itself. Okay, so the idea of that is purely to give me this actions on create position every 15 minutes, where I can update my staff on duty variable. I'm going to need another counter to add into the model to do this. So I'm going to create another variable. I'm going to call this time slot. Okay, and I'm going to use that in my trigger. I first of all need to initialize that as well in my initialize actions. So I need to say time slot equals 1 as my first to initialize my first time slot in the model. Back into trigger, back into my actions on create for trigger, and this is where I want to update my time slot. So I'm going to say time slot equals time slot plus 1. So that's going to increment every 15 minutes. All I need to be careful of is when I get to the end of my day at slot 96, if time slot equals 97, then I want to reset it back to 1 again. So I reset my time slot back to 1. And now the crucial bit, I need to reset my on duty to be equal to the staff variable brackets, and then use the time slot marker to tell me which of the time slots I'm looking at in my staff variable. So that means every 15 minutes the on duty variable will be updated with the number of staff on duty. Okay, I shall save that again. Now when I start running this model, then we can see the number of staff on duty changes every 15 minutes. I've run this rather quickly, so that's working fine. And now I simply need to put in my agent here. I need to say if n less than equal to on duty, pull from the call queue. End if. Okay. So now when I run my model, let's slow this down a little bit. What's happening is at this point in time I've only got 2, now I've got 3 staff on duty. So as I go through the day, now I've got 4 staff on duty, but it's only because I'm using the value of n within my agents, and I know I've never got more than 10 agents on duty in this model, then I am now using the correct number of staff on duty. And in fact now if I fast forward this through to the end, I can see overall I've achieved an 88% performance in my model in terms of answering calls within 30 seconds. I've lost 34 calls with this staff profile that I've had on, but I've quite quickly generated here a very flexible call center modeling tool, and I can now use that to adjust the call volumes, my staffing profile, and work out how many staff I need on by time of day to achieve whatever level of call performance I might need. The final piece of this was to add some resource in, and we're getting fairly close to time, so I shall very quickly add in a resource into this to represent the computing element. So we might have a resource, we ought to really give that a new style, so I'll just alter the display of that, and make it look a little bit more like a computing resource. So somewhere we have a computing resource. I'll turn it red. And now simply against the agents in the label rule, I can say something like, hold on, I need to, if I rename my as something like software, okay, and then in my label rule I can simply refer to that. Let's say if random is less than 0.8, then software is the rule I'm going to use. Sorry, just put some brackets in there. And now when I run this, we're going to be using a software constraint which will affect the call performance in the system. Okay, well, we've run right up against time there. If I come back to just close this off, the next webinar is scheduled for the week beginning the 24th of February, which will be on Witness Excel connectivity. So hopefully you'll be able to join us for that. This will be published on YouTube as a video, and I will try and address any questions that we've had via the chat, or alternatively you can always contact us at support@lanner.com. Thank you very much indeed for your time.